Hi, my name is Jose. I'm a full stack consultant based in London, and I'm the founder of microapis.io. I'm also the author of Microservice APIs in Python by Manning. I'm really excited to be talking at Manning's API conference, where I will talk about development workflows for delivering successful API integrations. If you have experience working with APIs, you probably noticed that delivering and managing API integrations is not always easy. As the complexity of our APIs grows, so does the risk of API integration failure. In this talk, I'll show you how documentation-driven development can help us to manage and reduce the risk of API integration failure. With this approach, we can use various tools and frameworks to validate the server implementation of the API and also to build our API clients against the specification. I'll show you how you can incorporate these tools and frameworks into your continuous integration process to make sure you can validate your APIs before you even release them. Hi everyone, thank you for attending my presentation, and thanks to Manning for organizing the event and for giving me the opportunity to participate on it. My name is Jose, and today I want to talk to you about API development workflows for successful integrations. But before I do that, let me say a couple of words about myself. I'm an independent contractor based in London. I work as a full stack developer, and for the past few years, I've worked with multiple clients, helping them to build microservices platforms and to deliver API integrations. As a result of this experience, I got the idea to put together the learnings that I made along this journey and put them together into a book. The result of this work is Microservice APIs in Python. There is a book published by Manning. It's currently available through Manning's Early Access program. Which means it's still in development. So if you read the book and you see something that is missing, that you don't agree with, or that you think should be changed, you can give me that feedback and I can incorporate that feedback into my book. I'm also the co-founder of microapis.io. This is a company that offers consulting services for businesses who want to build microservices platforms or API integrations. And it also offers you a nice interface where you can mock your APIs. You just need to paste the API specification into this panel. You click this button and you get a base URL for your mock server. Please connect with me. I love to connect with new people. So please reach out to me in any of these platforms, in Twitter, GitHub, Medium, or LinkedIn. I really like to connect with new people and exchange new thoughts and ideas. So please do so. Now, what's the agenda for this presentation? So first of all, I want to talk a little bit about the complexity of API integrations, why they're so tricky, why they tend to fail so often. Then I want to talk about some of the strategies that we can use to manage and to reduce the risk of API integration failure. In this context, I will introduce the concept of documentation-driven development. I will explain what it is, how it works, and how you can incorporate it into your API development process. I will also talk about a little bit about API visibility and how API visibility can help us improve the feedback loop between the users of our API and the development process that we make to our APIs. I've put together a GitHub repository with some of the examples that I offer in this presentation. So if you want to tinker with the code, you want to try out the commands that I'm going to show, or you want to see how things work in practice, feel free to check out the code in this repo and play around with it. Now, let me picture briefly the situation that I typically find when I'm working with a client on API integrations. So typically we will have two teams, one working on the client and another team working on the server, roughly in parallel. And what happens is at some point we deploy the API server, then we deploy the API client, we get them talking to each other, and the API integration fails. Now, what takes us to this situation where the integration fails? And obviously there are multiple factors, anywhere from bugs in the backend or in the front end to problems with the database or the network or the authentication layer. All of these factors, of course, can play a role into this result. But when it comes to the API itself, there are a number of factors that more commonly drive us into this situation. The first of them is when we drive changes to the API exclusively from the backend without thinking too much about the consumers, about the API clients, the users of the API. And this typically happens when we don't think of an API as a product. And that's funny because if you think of it, an API is just an interface, just like a user interface, like a browser application. And when we build those kinds of interfaces, we give a lot of importance to elements like user experience. So the same thing happens with an API. An API is just another type of interface towards an application. And it's very important that we pay attention to, in this case, we call it developer experience, how easy it is for developers to discover the API and to play around with it and to integrate, to build applications that actually play nicely with the API. Another problem that we find very often in this context is lack of separation between the different layers of the backend application. So we may not have, a clear distinction between the API layer, the database layer, and the application layer. And often what happens is we just end up streamlining our database models all the way through HTTP into our clients. The problem with this is, obviously there is no validation in the middle. There is no, transformation of the payloads and stuff like that. But the main problem is if we ever run a migration in the database, changing some of the fields, that's going to cause an integration failure immediately. So we need to have separation of consents, validation across different layers of the app, and things like that. Another, perhaps the most common factor leading to API integration failures is misunderstandings between the API client team and the backend development team about what the API is, what it should be doing, and what we can expect from it. And finally, obviously, lack of validation. If we are not validating our code, we can hardly expect it to work successfully. Now, let me focus a little bit more on the misunderstanding bit. So API misunderstandings come in many forms and shapes. It can be misunderstandings about the formats of some of our data fields. A classic example in this case is date fields. We may be expecting different formats in the client and the backend. There might be also misunderstandings about the data types. And this happens more often than you would think, especially in internal APIs for private use in different companies. So we may have integers represented as strings, booleans represented as strings. Obviously it's not the best thing to do, but if this is what you've got, it's fine as long as you are documenting it correctly. The problem is if we don't have any kind of documentation, these kind of situations are super misleading, and they are very likely to lead to API integration failures. Now, one of the most common sources here of problems as well is whether we understand correctly or not what is the expected shape of a payload. What are the optional properties? And this is especially important for a client when it's receiving payloads from the backend. So what are the properties that we definitely should expect in the payload, and which properties are optional? We have to build our code in such a way that it is resilient to those optional properties. They may not be present, so we have to know what to do in those situations. Now, what are the most common causes of misunderstanding about the API between the client development team and the backend development team? So there are a number of factors that can lead to this situation, but more often than not, it is the result of lack of API documentation. This is extremely often. Instead of API documentation, we have stuff like JSON examples. The problem with JSON examples is they tend to be incomplete and they tend to be misleading. A JSON example can't tell you everything about the data types and formats of specific fields. It definitely cannot tell you whether certain fields are optional or not. It's just an example of a payload. It's not a description of the payload. And also, JSON examples tend to become deprecated very quickly. As the API changes, you will have to change all the JSON examples that you have. And that's cumbersome. Nobody wants to do it. They become deprecated very quickly. And they become a misleading source of information about what you can expect from the API. So don't use JSON examples if you can. Now, another situation we often encounter is we have documentation, but sort of. It's not really documentation. It's more like free-form documentation in platforms like Google Docs, SharePoint, Confluence, and it's written in a non-standard format and often in an incomplete way. So the main problem with this type of documentation is it cannot be used with any of the existing tools and frameworks that can help us, run automatic tests against an API, make visualizations of an API, get an API client straight away out of the documentation and things like that. And obviously, one factor here as well is lack of a design stage. If we're not designing our API as a product, with the API user, the API consumer in mind, then we're not building for them, and it's perfectly normal that what we do is confusing for them. So it's very important to have a design stage in the API development process. It's important that we build the APIs for our clients, for the consumers, even if those consumers are within our own company. But we're building for them, and we have to make it easy for them to discover and understand our APIs. Now, these factors are so common. These situations happen so often that they led me to think that there's kind of a fundamental law of API integrations, which is that no API survives first contact with its client. Now, the most important question is here, what we can do about it. And the first thing we need is API documentation. And what is API documentation? Well, that depends on the type of API that you're using. If you're building a REST API, you want to use something like the OpenAPI specification format to document your API. If you're using GraphQL, that is going to be the schema definition language. And if you're working with gRPC, then you have to use protocol buffers. These are just some examples of the main types of APIs, but usually every type of API has its own preferred documentation format, and you should be striving to stick to that standard format. Now, once we have documentation, there are lots of things we can do. We can drive changes to the API backend and to the API client from the documentation, and we can use the documentation to validate our code. This is what I call documentation-driven development. And you may have come across this concept under different names like design first, API first, or contract first approach. The basic idea is you produce the API specification first, and then you build the API server and the API client against the specification. And then you use the specification to validate the implementation of the client and the server. Now, this is the kind of the simplified feedback loop in this workflow process. We will go first through an API design stage. Out of it, we produce an API specification, and then we use the specification to build the server and the client. Let's zoom into each of these two steps, the client and the server, a little bit more to see in detail how it works in practice. So what is the API server development workflow? So using documentation, the first thing we want to do is we want to build the server against the specification, and then we want to use the specification to validate the server. So we can use certain tools and frameworks to run automatic tests against the server without us having to write a single line of code. One of these frameworks, it's a classic. I believe the first one of its kind is Dret. So Dret is an npm package. So you install it with npm. You need a Node.js environment in your machine to be able to use it. And Dret is a tool that looks at the API specification that you want to test. Then you have to give it the URL that it can run the test against. And optionally, you can give it the command that it needs to use to start up the API server. With Dret, you can also use hooks. In the repository that I prepared for this presentation, you can find an example of Dret hooks written in Python to see how it works. So a typical Dret test suite will test all of the endpoints in our API, and with different payloads and different situations to make sure that it's working in all the expected situations. Now, another tool we can use to validate the API server is Schema Thesis. Schema Thesis is a Python package, so you install it with pip and you run it the same way. So you need to pass it the API specification document, as you see here. You give it the base URL of the API server, And optionally, you can run it with links. So links is a concept in OpenAPI that allows you to establish the connections between different endpoints. So with links, you can say that things like the post endpoint is returning an ID, a payload with an ID that you can use to then retrieve the details of these resource using the get resource plus ID endpoint, or to update the resource or delete it. So that's what's happening in this example. You can find the example in the repository. But basically, schema thesis is testing the get and the post generic resources of the API, and then it's using links from the post endpoint to run specific tests on the get, the put, and delete endpoint with the specific resource that was created. And then it's running a bunch of additional tests on the get, put, and delete endpoints. In total, schema thesis is running over 700 tests against the API. So it's a very comprehensive test suite. And I really recommend that you use either Dread or schema thesis, perhaps both in combination. There may be things that schema thesis can catch and Dread can't, and the other way around. But definitely include these tools into your API development workflow, because they can save you so much time. You don't have to write the test manually. These tools are designed, by experts in the field to save you the time of doing that. Now, what does the development workflow look for the API client developer once we have documentation? So once we have documentation, we can use mock servers to build the client against the spec. And I don't know if you have experience building API clients, especially things like browser applications, but having a mock server is a lifesaver, because in the absence of a mock server, you have to work against the actual API server, or you have to work against replications of the server based on custom stubs that you have to write, which may or may not replicate the API server correctly. But a mock server is strictly based on the API specification, and it is going to give you exactly what the API specification requires from the server. This is useful because you don't want as a client developer, you don't want to be bothered with the overhead of setting up the backend server in your local machine, or testing against it in the cloud, where some other people may be running tests in parallel and perhaps missing the state of the app. And the API server may contain some bugs for those specific features or elements that you want to test with the client. So with the mock server, you have none of that. Obviously, at some point you have to test with the real server as well. But while development is going on, you don't have to be bothered with any issues in the actual server. You can test against the mock, which is the specification itself. Now, there are various tools and frameworks that you can use to run mock servers. I'm going to show you a couple of examples here. One of them is with Prism. So Prism is a NPM tool built by Stoplight. It allows you to run mock servers locally. So to install it, you use NPM, and to run it, you use the command with your node modules folder. So an example here of what it looks like. This is calling the local mock server of a to-do app, which is included in the repository for this presentation. So you can see here what it looks like when you run calls against the server. In every case, you're getting perfectly valid payloads. Now, if you don't want to run the mock server locally, or for some reason you can't, perhaps because you're working on a continuous integration server with limited resources, in those cases you can use mock servers in the cloud. There are various different providers with which you can do that. In this case, I'm going to show you an example with micro APIs because, to my knowledge, it's the only platform where you don't need to have an account to be able to run mock servers. So what you would do in this case is, like I said at the beginning, you would paste the specification document into this panel, and then you get the base URL of the mock server that you can use to start making calls to it. And this is an example of a call to the server. Now you can do the same process with the CLI, just calling the macro API's API and sending it the specification document. You will get a payload with the ID of your mock server, the base URL, and also a sample URL that you can use to test that the mock server is working correctly. This is an example of calling the sample endpoint and the return payload that we get from the server. Now, the same thing happens if you're working with GraphQL servers. There are plenty of tools and frameworks that you can use to run mock servers. In this case, like my favorite is GraphQL Faker. GraphQL Faker was built by the APS Gurus team. It's an NPM package. You run it in a similar way to Dread or Prism with the GraphQL Faker command within the node modules folder and pointing it to the specification document of your API. This is an example taken from my book, the chapter dealing with GraphQL APIs, where we built a products API. So GraphQL Faker gives you a GraphQL interface, which is a very useful interface where you can build your queries and mutations against the GraphQL API. It also allows you to inspect all the data types and their relationships. It corrects your queries as well. So if you haven't tried GraphQL Faker yet and you're working with GraphQL APIs, you should definitely try it out. Now, once we have all this tooling in place, we can run these tests into our continuous integration server to make sure we validate our APIs before we even release them. So this is an example of a Travis document configured to run Dread and Schema Thesis tests against our API. Please refer to the GitHub repository for the document to be able to copy paste what's going on here. So with something like this, we are in a position where anytime we push our code to GitHub, every time we raise a pull request or we match into master, our code is going to be tested and validated, and we are not going to let anyone release any code that is breaking the API. Now, one question that often comes up in the context of this kind of discussion is that the process that I'm describing sounds ideal, but, big but. The thing is that designing APIs requires a little bit of tinkering and experimentation. So how are you going to build, how are you going to produce the API specification document if you don't have something fast that you can try and work with? And the other thing is, what about those frameworks that allow you to, write the code fast and then generate the documentation? My answer to this is none of these things are necessarily incompatible. You can do all the tinkering and experimentation that you want with your code, and definitely you can use these code first frameworks to generate some part of the documentation. But what you shouldn't do is to drive changes to the API with this method. Before you consolidate the API, you finish the design process, the design stage of the API development process, then you consolidate the API specification, and this may require changes to the specification that you produced with this code first approach frameworks. And that's perfectly fine because you're building for the client, not for yourself. And then you're in a good position to start building or to finish building the API server and the client. Now, here's the other thing. Is that I don't believe humans should be writing huge YAML or JSON files. To design API specifications, there are plenty of tools these days like Insomnia Designer, Stoplight Studio, or Postman's API Builder. Feel free to check out any of these tools. I haven't personally worked with them, but they're very popular and they can save you a great deal of time and effort when you're designing your APIs. Now, a situation that commonly happens here is that we may already have an API in place which is not documented. And how do we deal with that? Well, the first thing we need here is an API observability tool. One of these tools very popular now is Akita. So Akita looks at the traffic between our API clients and the API, and it's capable of inferring the API specification of our API based on the exchange of payloads. Now, once we have this specification, what we should do is consolidate the specification and use it for testing the clients and the server separately referring back to the original development workflow that I described. And then, this process has to be repeated many times. Anytime we have to make a change to the API, we go back to the API design process, we produce a new specification, we require the new specification is incorporated into our continuous integration process. So it's going to invalidate any new changes to the backend which are not incorporating the new changes to the API. So once we publish the new API, we are under the requirement of making changes to our API server and our API client. Another thing that API observability tools can do is continue looking at the traffic, and they can help us to see if our clients are understanding the API or not. So if we see a lot of incoming payloads with consistently wrong formats with a specific pattern, then we can think that there is something wrong with our documentation, something that is not clear, and that can help us improve our API documentation and design. Now, this is everything I wanted to say. I hope you found this talk useful. And again, if you want to connect with me, please feel free to do so in Twitter, GitHub, Medium, or LinkedIn. And please, if you found this talk interesting, feel free to check out the book, Microservice APIs in Python. Thank you so much for attending, and I look forward to your questions.